Hello students, today we'll start with the balancing of redox reactions in terms of half reaction method. So in this method, the two equations are balanced separately and then added together to give balanced equation. We'll see this half reaction method, or this is also called as ion electron method, and we'll see this balancing under two cases. One is acid medium and the second one again is your basic medium there. Look at this question. This is the question we need to balance. Fe in +2 state reacts with Cr2O7 minus, give Fe in +3 state plus Cr in +3 state. You need to balance this equation by ion electron method or half reaction method in acid medium. I'll show you here how to do on the board. Pay attention. It is Fe2 plus half reaction method we are studying. Half reaction method. And we'll be balancing Fe in +2 state reacts with dichromate ion Cr2O7 2 minus to give Fe in +3 state plus Cr in +3 state. And this is in acid medium you need to balance. In this balancing, that is by half reaction method or ion electron method, you need to divide the equation into two half cell reactions. That is your oxidation half cell reaction and the second one is reduction half cell reactions. Firstly, I'll compulsorily divide this into two half reactions. Fe2 plus goes to Fe in +3 state. Here iron is balanced. I need to balance the charges. Here iron is present in +2 state and on the right hand side Fe is present in +3 state. So it is increase in oxidation number. This is a case of oxidation and I need to balance here electrons +2, here it is +3. I'll add one electron on the right hand side to balance this equation and this becomes equation 1 and you will name this equation as oxidation half cell reaction. Oxidation half cell reaction. Then you will do the second case. You will go for balancing of dichromate ion Cr2O7 2 minus. So here you see I write Cr2O7 2 minus goes to Cr in +3 state. Calculate the oxidation number of chromium on the left hand side. It comes out to be +6. And chromium here on the right hand side is present in +3 oxidation state. Correct? Balance the number of chromium atoms on both the sides. So I'll put here 2 on the right hand side. I put 2Cr3 plus. Then I'll balance the oxygen atoms. To balance the oxygen atoms, I'll add 7H2O on the right hand side. 7H2O. Then I need to balance H plus. Balance H plus, since this is in acid medium, I need to balance H plus. To balance H plus, I'll add 14H plus on the left hand side. So I add 14H plus on the left hand side. Then the last step for balancing this is to balance the charges. Here the charge that is present on the left hand side is 2 minus plus 14. So 12 is the charge that is there on the left hand side, and on the right hand side it is 6. Now to balance the charges, I need to add electrons on any one side. Here you see from plus 6 state it is going to plus 3 state, chromium. This is decrease in oxidation number. So this is a case of reduction. And both oxidation and reduction reactions are occurring simultaneously. So it's a case of redox reactions there. Now I'll be balancing the charges in equation 2. This is reduction half cell reaction. I'll add 6 electrons on the left hand side plus 6 electrons. And this is my well balanced equation, equation 2. And I'll give the name to this as reduction half cell reaction. Reduction half cell reaction. Reduction half cell reaction. This is equation 2, and this was oxidation half cell reaction, equation 1. Now, the next step is I'll add these 2 electrons together. Before adding, you need to make the electrons same on both the sides. I'll add 6 electrons here plus 6 electrons. Gives. Right? Here it is 1 electron and here it is 6 electrons. I'll neutralize the electrons on both the sides. I'll multiply equation 1 with 6 and equation 2 with 1. And we will add these 2 equations together. We need to add those 2 equations together. When you add, we get 6Fe2 plus Cr2O7 2 minus plus 14H plus gives 6Fe3 plus 2Cr3 plus 7H2O. Now see, I'm writing this equation here on the top. And on adding the equation, we get this answer as 6Fe2 plus Cr2O7 2 minus plus 14H plus gives electrons, 6 electrons get cancelled there. Gives 6Fe3 plus 6Fe3 plus 2Cr3 plus 2Cr3 plus 7H2O. So my answer after balancing comes out to be 6Fe2 plus Cr2O7 2 minus plus 14H plus gives 6Fe3 plus 2Cr in plus 3 state plus 7H2O respectively. So this is how we'll be balancing. This is your answer. This is how you will be balancing by half reaction method or ion electron method in acid medium there. Next we'll be seeing the balancing of this redox reaction in terms of your basic medium. We'll be seeing in basic medium there. Look at this problem. The question is permanganate ion MnO4 minus in basic solution oxidizes iodide ion I minus to produce molecular iodine I2 and manganese in +4 oxide, that is MnO2. Write a balanced ionic equation to represent this redox reaction? That is the question which is given to you. And let's balance this equation in basic medium. To balance this equation in basic medium, firstly, you need to write that equation in ionic form. So we'll write that equation in ionic form. Look at the question, and it will be given in the form of word problems to you. This is how it will be given. Permanganate ion is 7, present in +7 state. So you need to write that equation, ionic equation, MnO4 minus reacts with iodide ion, I minus, to give MnO2 plus I2. You need to balance this equation in basic medium. So to balance that equation in basic medium, I read out, it is MnO4 minus plus I minus gives MnO2 plus I2. Again, you will divide, and it is in basic medium. You will divide this equation into two equal half cell reaction. One is oxidation half cell reaction, and the second one is reduction half cell reaction. Firstly, you see, I minus goes to I2 state. I minus is present here in -1 state, and I2 is present here in 0 state. Increase in oxidation number, this is a case of oxidation. Firstly, I'll balance the iodine atoms. I'll put 2I minus, and here it is I2. Then charges, since here it is -2 and here it is I2, I'll add 2 electrons on the right hand side. This is oxidation half cell reaction, the first equation, and it is oxidation half cell reaction. Oxidation half cell reaction. Then the second case, it is MnO4 minus goes to MnO2 state. Calculate the oxidation number of manganese in both the cases. On the right hand side, Mn is present in +4 state, and here MnO4 minus manganese is present here in +7 state respectively. Now, to balance this equation, you will first see the oxygen atoms there. Here there are 4 oxygen atoms. Here there are 2 oxygen atoms. The side that is deficient in oxygen atoms, add that many number of water molecules to that side. So here I'll add, since here 2 oxygen atoms are deficient, I add 2 molecules of water on the right hand side. Next, I need to balance the H plus ion, 2 into 2, 4. So I'll add 4 H plus ions on the left hand side. And since I need to balance this equation in basic medium, the number of H plus ions I have added on the left hand side, I'll add the same number of OH minus ion on both the sides. So I'll add 4 OH minus on the left hand side, and also I'll add 4 OH minus on the right hand side. We'll add OH minus, same number of OH minus on both the sides. Then we know 4H plus plus 4 OH minus, H plus plus OH minus is equal to H2O. Similarly, 4H plus plus 4 OH minus is equal to 4H2O. So I'll make this as 4H2O. 4H2O. I made that as 4H2O. Now H2O is common on both the sides. Here it is 2H2O, here it is 4H2O. I'll bring this 2H2O on the left hand side and it takes the form of and this becomes 2H2O plus 2H2O. Now you see this becomes MnO4 minus plus 2H2O gives MnO2 plus 4OH minus. I balanced all the atoms that are present here, manganese, oxygen, hydrogen. Now I need to balance the charges. To balance the charge, you see on the left hand side, the charge which is present is -1. And here on the right hand side, the charge that is present is -4. Here it is -4 and here it is -1. I need to add the electrons and this is +7 to +4. This is your reduction half cell reaction that is undergoing it is. So here I'll add on the left hand side 3 electrons to make the charges equal. I'll add plus 3 electrons and here it becomes the reduction half cell reaction equation 2 and it is reduction half cell reaction. You need to mention there reduction half cell reaction. I hope here it's clear to all. Next, I'll make in equation 1 and equation 2, you need to make the electrons same. For that, you'll multiply equation 1 with that of 3 and multiply equation 2 with that of 2. We are neutralizing the number of electrons. I'll multiply equation 1 with 3 and equation 2 with 2. And we'll add these two equations together. You'll add equation 1 and equation 2 together. So we get into 2, 6i minus plus 2MnO4 minus plus 4H2O gives 3i2 plus 2MnO2 plus 8OH minus. I'm writing that equation on the top here. I'm writing. And that becomes my well-balanced equation. So my equation is 6i minus plus 2MnO4 minus plus 4H2O gives 3i2. If you write I minus first, then on the right hand side also, you will write I2 related. Then after you will put manganese. So 3i2 plus 2MnO2 plus 2 into 4OH minus, that is 8OH minus. So you will write there 8OH minus. And this becomes your well-balanced equation by ion electron method in basic medium. So my answer comes out to be 6i minus plus 2MnO4 minus plus 4H2O gives 3i2 plus 2MnO2 plus 8OH minus respectively. So that's how I get my answer, and that's how we'll be balancing the equation using ion electron method or by half electron method there. Thank you, children. In the next class, we'll be studying about redox reactions and electrode processes in detail. Till then, have a nice day.